Okay, so this is day 2. This should be lesson number 19. It says, what's the complement of an angle with a measure of 19 degrees? And so I remember the word complement. What I should be thinking about in my head is a 90-degree angle. And so if I'm talking about the complement of 19 degrees, then I'm going to do 90 minus 19. And that's going to give me 71 degrees, okay? Because 71 plus 19 is 90. In the second situation, it says triangle HOT has two measures, one of 45 and the other 60. What's the third? Well, yesterday we learned that triangle, the sum of the interior measures is 180. So I'm going to do 45 plus 60, which is 105. And then I'm going to take that and subtract it from 180. Because all triangles have, and I got 75 degrees, so the other angle will be 75 degrees. All right, let's learn something new today. So today is, we're going to learn about a corollary. So a corollary is a theorem whose proof follows from another proof. So yesterday we proved that all triangles add up to 180 degrees. So that means that if you know that one angle is a right angle, then you know the other two angles. So this would be a corollary. If we know that this one's 90 degrees, then you know that this angle and this angle have to add to give you 90 degrees. So they're complementary because angle 1, or angle A, plus angle B has to equal 90 because 180 minus 90 is 90. So these two have to add up to 90 degrees. In a second corollary is now we can prove that if you have an equilateral triangle, right, all the angles are going to be 60 degrees. And the reason for this, again, is if you have 180 degrees in a triangle, and there are 3 angles, and each of them are equal, 180 divided by 3 is 60. Therefore, that's why equilateral triangles have 60-degree angles. Now let's look at the second situation. Says MOP. MOP, you've got a 35 and a 30-degree angle. So again, you're going to take 35 plus 70 plus x, and that's going to give you 180. And so in this case, we can figure out that x is going to be 180 minus 105, which we know is 75 degrees. Now down here, we're telling you now if you know that one is 70 and the other one's 35, so the order doesn't matter, then you can say the third one is also going to be 75 degrees because all 3 have to add up to 180. Seems like you're kind of pointing out the obvious, right? So we're going to fill in the blanks. This is called the third angles theorem. So if you know 2 angles in one triangle, like this, we know 2 angles in one triangle here, 35 and 70, and we know 2 angles in a second triangle, then you know that the third angle is also going to be congruent to each other. So the third angles are also congruent. All right. So let's take a look. This is also an exploration for the next thing that we're going to learn, and this is called exterior angle. So we've got this exterior angle right here, and I'd like you to go ahead and measure each of these interior angles to the best of your ability using a protractor. Pause the video, go ahead and do that, and come right back. So when you measured each angle with a protractor, you should have noticed that the measure of angle 1 is 35 degrees. The measure of angle 2 was 120 degrees. And the measure of angle 3 was 155. And so the question is, what conclusion can you draw? Well, if you add 135 plus 120, 35 plus 120, you actually get 155. And so the conclusion you can draw is that if you add the angles that are non-adjacent, right, or across, remote from the exterior angle, you actually get the exterior angle. So how does this look? Let's look at a couple more examples. So if over here we want this exterior angle here, I know that I can add these two together. So I can add angle 3 and angle 2, and that'll give me angle 1 over there. So following that same theory, I can say that these two added together are going to give me this angle here. So let's do 72 plus 45, and that's 117. So that means that x equals 117. And here, it's following the same theory. I'm going to add those together, and they're going to equal this outside angle. So this one I got to do a little bit more work. 8x plus 15 is going to equal 3x plus 4x, that's 7x. 20 plus 5, that's 25. Please excuse me. Right? So I'm going to subtract 7x. 8x minus 7x is x. Now I'm going to subtract 15. So x equals 10. Now I know what 10 is, but I guess that's all they wanted me to do was find x right here. If I wanted to, then I could plug it in. And if I plugged in 10 here, I would get 80 plus 5, that's 95. And if I plugged in 10 here, that'd be 30 plus 20, that's 50. And here, that'd be 40 plus 5 is 45. And you can see that 50 plus 45 is 95. So we worked it out correctly. Okay, so now let's look at a couple more examples following the same rule. We know that this is angle 1, 2, and 3. So we're going to call this angle x, this would be angle 2x, and this would be angle 3x, because they're in a ratio of 1, 2 to 3. But we know with certainty that adding them all up is going to give us 180. So you simply just combine your like terms, so that's 6x equals 180. So if I divide by 6, x is going to equal 30. So I know the smallest angle is 30. This one's 60, and this one's 90. Okay. Example 4 says one of the acute angles in a right triangle is 61. So I know this is 90. So I'm going to say this is 61 degrees, and we want to know what is this one. Well, there's a couple ways to do it. Using the theorem, though, I'm just going to do 90 minus 61, because I know that these two angles have to add up to 90 degrees. And I end up with 29 degrees. So one angle is 29 degrees. At this point, you've learned enough theorems to go ahead and get started on your homework. A couple things I want to point out to you is that you're looking at triangles A, B, and C. Now, what type of triangle is ABC? Well, you need the third angle measure to be able to figure this out. You have A and C, so far for number 1, it looks like it's going to be acute, but you need to find out what angle B is to figure out what type of triangle it is. Because remember, if it's an obtuse angle, then it's going to be an obtuse triangle. If it's a 90-degree angle, then it's going to be a 90-degree triangle. And if it's an acute angle, then it's going to be an acute triangle. Okay. Again, this is a ratio problem, so please remember that you've got a triangle. One corner is 1x, then we've got a 3x, and we've got a 5x. But if you add it all up, blank plus blank plus blank, it's going to equal 180 degrees. Okay. Let's see, in number 3 it says, in triangle DEF, the measure of angle D is 37, the measure of angle F is 56, find the measure of exterior angle E. Okay, so this is going to look something like this. This is the one you're looking for. This is D, and this is F. Okay, and then you can see the same sort of picture on the right. Okay, let's see what else we got. Again, this is one where you could set it up a couple different ways, but you know that these two have to add together to give you 90, right? Because the other side is 90. And here are some more diagrams. Once again, you're going to be looking for an exterior angle for these. And so in this case, here's our exterior angle, and we know these two are going to add up to give you that exterior angle. So I'm going to say x plus 60 equals 100. So I would subtract 60 from both sides, and I can see that x is going to be 40. Okay, and these you solve in a similar fashion. Please remember that the two interior angles are going to add together to give you the exterior. So this would be like 80 plus 6x minus 8 equals 14x plus 8. And then you go ahead and solve this just like you would any other algebraic expression. Okay, so this is your homework. You need to finish the packet. And then you also need to work on, I believe it's IXL, F1, F2, and F3. And this is geometry. Due Friday. These three are due Friday. Today is a great day to get them done. If you have any questions, please raise your hand. You may also re-watch any parts of the video that you still have questions on. And please note that this part back here, we didn't solve these problems, I just helped you set them up.